NEC Section 810.21F addresses the grounding of antennas and antenna supporting structures, stating that they must be grounded according to the requirements of Part 1 or 2 of Article 250, in addition to its own specific requirements. Specifically, 810.21F focuses on attachments to other grounding conductors. This section mandates that when an antenna is mounted on a metal mast, the equipment grounding conductor from the antenna must be securely connected to the metal mast. This connection is in addition to the connections required by both 250.104A and 810.20A. Now let's examine the additional sections that 810.21F references. NEC Section 250.104A covers the bonding of certain metal parts. It stipulates that the equipment grounding conductor must be connected to the system grounding electrode conductor at the service entrance, or alternatively, to the grounded conductor at the service equipment or transformer. This provides options for ensuring a solid grounding path for the antenna system. NEC Section 810.20 deals with acceptable grounding electrodes. It explicitly states that grounding electrodes, as described in 250.52A through F, shall be used for grounding antennas and antenna supporting structures. The reference to 250.52A through F is critical because it defines what constitutes an acceptable grounding electrode. These electrodes include things like metal underground water pipes, metal frames of buildings or structures, concrete encased electrodes, ground rings, and rod and pipe electrodes. Therefore, when assessing the specific installation you described, where the grounding wire from an antenna mast is attached to the grounded service conductor or guide wire of the service drop using a split bolt, several factors must be considered to determine code compliance. The key is to ensure that the service drop is indeed connected to a grounding electrode that meets the requirements outlined in 250.52A through F. This means that the service drop's grounding connection must ultimately tie into one of the approved grounding electrodes, such as a metal water pipe that's in contact with the earth for at least 10 feet, or a ground rod driven into the earth. Another important factor is the secure connection of the equipment grounding conductor from the antenna to the metal mast. This connection is required in addition to the connection to the grounded service conductor. It is also important to remember that the connection of the grounding conductor to the grounded service conductor should be made with a listed connector suitable for the purpose, such as the split bolt connector. This will ensure a reliable and safe connection. If both of these conditions are met, firstly, the service drop is connected to a grounding electrode that meets the requirements outlined in 250.52A through F, and secondly, the equipment grounding conductor from the antenna is securely connected to the metal mass, and it is likely that the installation is in compliance with the NEC. However, it is important to note that the final determination of code compliance rests with the local authority having jurisdiction, which is usually the electrical inspector. They have the authority to interpret the code and make the final decision on whether an installation is compliant. Therefore, it is always a good idea to consult with the local electrical inspector before making any changes to an electrical system. Also, it's important to emphasize the difference between a grounded conductor, which is typically the neutral wire in an electrical system, and a grounding conductor, which is used to provide a path for fault current to return to the source. While it may be permissible to connect the antenna grounding wire to the grounded service conductor under certain circumstances, it is never permissible to connect it to an ungrounded conductor. It is also important to ensure that the grounding conductor is sized appropriately for the application. NEC Table 810.16 provides guidance on the minimum size of grounding conductors for antenna systems. The size of the grounding conductor should be based on the size of the antenna conductors. Finally, it is important to note that the NEC is a minimum standard. It is always permissible to exceed the requirements of the NEC, as long as the installation is still safe and meets all other applicable codes and standards. For example, you could use a larger grounding conductor than what is required by the NEC, or you could install additional grounding electrodes. This is generally encouraged to improve the safety and reliability of the electrical system.